Okay, so what's really happening here? What's on the top? 7 x's. X times x times x times x times x times x times x. 7 x's are up on the top. What's happening on the bottom? 3 of them. Okay, so actually, when you have 7 of them on top and 3 on the bottom, they're all being multiplied together. You can cancel this one and this one. Let me do that in red. You can cancel this one with this one. You can cancel this one and this one. Bless you. And you can cancel this one and this one. What do you have left? 4 x's, which means x times x times x times x. So it's x to the 4th. That's what's really happening. Now, what's the shortcut that we usually just use? Just subtract. Good. When one's on top and one's on bottom, you subtract them. And here's the thing. When one's on top and one's on bottom, you subtract it. And your answer, your remainder goes where the highest number was to begin with. Whether it's on top or bottom, it doesn't matter. Here, the 7 was on top, so our answer, x to the 4th, is on top. So 2 matching bases where the bases are the same, where one's on top and one's on bottom, means subtract. However, this may be different than what you did in younger grades, but we're not always just going to put the number on top. We're going to put the number where the largest exponent was to begin with. Turn over to 10-3. I think it says 10-3a, but it's the first one that you see. Right in, that's dividing powers. All right, so 10-3, let's look at this example. Put your pencils down and just watch. A couple different cases here. This one would just simply be x to the what? 8, because 10 minus 2 is 8, and the 10, the biggest number, is on the top. All right, this one. Be careful, because they're not all just going to be on the top. Look at your m's. You've got an m to the 2nd, m to the 5. That's going to be m to the 3rd. But where's it going to go, top or bottom? Bottom, because m to the 5th is the bigger exponent. That's where the remainder would be, m to the 3rd. And let your n give n to the 4th over n to the 3rd. What would we get? Where? Top. Okay? That's it. Now, keep your pencils down and look at this case right here. What do you think? Think before you call it out and think about this. So it's going to be x to the negative 2 minus, don't write this down, minus negative 5. And what happens right here? And that's where she got the positive 3 from. That's one way to do it. Another way I'm going to do it is this way. That confuses a lot of people, and in all my years of teaching, I still see people trying to forget about that double negative right there, trying to make that into a negative 7, and I don't want that to happen to you. So try it this way also. X to the negative 2 goes where? Bottom. X to the negative 5 goes where? And now if you just do it that way, 5 minus 2 comes out to be x to the 3rd. And that way it's really easy to do it without making any little negative sign mistakes. Okay, so now pick up your pencils. Let's do a few together really quickly. In general, I move my negatives first so that I don't have to deal with them. Some of you could just go ahead and deal with your subtracting negatives, and that's fine as long as they're coming out right. Then I add what I can, then I subtract what I can, and then I reduce the numbers that are out in front. So number 1, subtract your n's, n to the 4th and n to the 1st. What do we get? N to the 3rd where? On top. So my n's are done, but I have 3 left over. Where does that go? Bottom, and it doesn't have anything to reduce with it. There's no number on top that reduces with the 3. That's your answer. Number 3, let's deal with the negatives first. So I'm going to rewrite everything else as it is. I write 2. I write p to the 4. I write 4. I write all of my things that don't have to change. Some of you might have already subtracted in your head. That's okay. But which one has to move? P to the negative 2, and it moves up to the top. It becomes p to the 2nd. I take this negative 1, and I move it up to the top. That alleviates a lot of the confusion. And now what we have left over is, on the top we have p to the 6th. Good. Now we have to reduce the 2 and the 4. The 2 reduces to a 1 and the 4 reduces to a 2. So all we're left with is a 2 on the bottom. The 1 on top doesn't have to be rewritten. That's it. P to the 6th over 2. Number 5. What happens first? What cancels out? The m to the 4th. Those are both gone. They equal m to the 0 if you want to do it that way, or they each reduce to 1. All right, end of the second, end of the third. Subtract it, you get n. Where does it go? Say it. The bottom. You go with the where the highest exponent is. End of the third is on the bottom, so that's where your remainder goes, and you're left with the 1 on top. Number 7. Okay, here's what I do. I write everything the same, and then I deal with my negatives. If something can cancel, that's fine too. These 4s can be gone. 4 divided by 4, they just reduce to 1. This x to the 0 can be gone. It just reduces to 1. What doesn't move is x squared and y4. They don't move. They're just regular positive exponents. Which one does move? Y to the negative 1. And now y to the negative 1 moves down to the bottom. Y1. Good. There's a 1 left on top since nothing else is there. Bless you. So now you have y over x squared. Doesn't have anything to go with, but the y turns into y to the 5th. Number 9. I don't see anything that can immediately cancel, so I'm going to write everything that doesn't change first. This a to the negative 1, it's going to change. This 3, does that move? No, we're going to keep it right there. A to the 2nd, does that one move? No, it stays where it is. It's a positive 2. B to the positive 4, does it move? Nope. The only one that moves is a to the negative 1. And where does it move to? The bottom. Okay, so that's what I do to help alleviate confusion. You move all the negatives first. Then you just simplify what you can. 1 and 3 are already reduced. A to the 3rd. A1 and A2, they become a to the 3rd. B to the 4th. Okay. On your own, try number 11. Anybody need more time just for number 11? Okay, so I would see that this could automatically cancel. You don't need that. That reduces to a 1. The K stays where it is. The H is positive still. And the J stays, the J is the only one that's going to have to move. So you got J to the negative 4. What happens with that? What happens with J to the negative 4? Up to the top. Becomes positive 4. You don't really need a 1 on the bottom. You only need a 1 if the top is empty. So H, I should put this in alphabetical order. It would go H to the 3rd, J to the 4th, and then K. Typically, you'll see the answers written in alphabetical order. Yes. So If it's on top, it goes down. If it's down, it goes up. Write out all the things that stay the same first, and then write the one that moves. Do that one last. All right, let's try 13 and 14 together really quickly so you guys can practice. Number 13, you tell me, what do you see to do first? Okay, we're going to move the negative 3. What else can I do right away? Reduce the x to the 0 to 1. That just becomes a 1. All right, nothing else is done in the first step. Some of you I know are going to mentally do this y squared, and that's fine. But let's do what we have left now. So we have 1 on top and 2 on bottom, y squared and z squared on top. And like I said before, there's multiple ways you could do this. You do whichever way ends up working for you. And that one's x to the third. X to the -3 moves up to the top. Then lastly, combine everything that can combine. You've got a 2 down here. Y to the second and y to the 4, that becomes y to the second. But where does it belong? The bottom, where the highest exponent was. Y to the second. Z to the squared doesn't move. X to the third doesn't move, but x goes in front because of the alphabet. And the last one. The 3 doesn't have to go anywhere. There's a whole lot of things that move. Is there anything there that cancels exactly? I don't see anything. Okay, so we put 1 on top and 3 on bottom. Let's rewrite everything that stays the same. This 3 doesn't move. This, say again? Okay, good. I'll move the things up in a second. This one doesn't move, and this one doesn't move. Everything else moves. I kept this one, I kept this one, and I kept this one, and kept them all where they were. So the h to the -2 moves up to the top. I did that one. H to the -3 moves to the bottom, becomes +3. J to the -2 moves to the bottom, becomes j squared. And k to the -2 moves to the bottom, becomes k squared. Sometimes I end up just crossing off one that I moved or I dealt with so that I don't have to go back and see which ones I haven't dealt with yet. So let's write in alphabetical order. There's only an h squared on top. Actually, let's even do better than that. What do you see? The h's can reduce. This h squared can reduce with this one. It's going to be h to the first where? On the bottom. So 3, h to the first. What letter goes next? The j's. J to the third, j to the second becomes j to the fifth. And then the k's. K to the fourth. And do we need a 1 here? Yeah. On the top you need 1. On the bottom you don't need a 1. And that's all you really have to be able to do. Okay, so you're combining, adding, subtracting, and moving your negative signs. Oh, turn the page. Let me just show you this on scientific notation really quickly. There's just 2. Actually, turn the page twice. We won't really need it. All right, so this time we're dividing. We're going to divide 6 divided by 3 as our coefficient, and then we're going to deal with our powers of 10. 6 divided by 3 is 2. Now look carefully. What would it be? 10 to the what? Second, that's a 7 and 5. Is it positive or negative? Positive. Okay, top minus bottom. In scientific notation, that's the only time you don't turn it into fractions. It's the only time the fraction rule doesn't apply. You can leave your answer with positives or negatives. All right, do we have to do anything more to this one? No, because there's only one number in front of decimal. There's only a 2.0, and so that's okay for scientific notation. For number 14, divide 2.4 divided by 8.2, and if it doesn't round or it's not exact, let's go to 4 decimal places. You can answer already? 2.4 divided by 8.2. Is that what you got? I see 0.2927. Do we agree with that? Okay. All right, times 10 to the what? First, 3 minus 2. You subtract them. And if the bottom number is bigger, your answer is going to come out to be negative, and that's okay for scientific notation. Is this one okay? No, we have 1 step further to go. The x is here, but we want it here. Which direction does that mean we have to go? Left. You want the dot, and you want to end on the x, so that's left 1. So think about it. If I have a negative 1 here, and I have a positive 1 here, what's going to happen? 10 to the 0, good. That one's to the negative 1, and then we include our times 10 to the first. This one, we moved the decimal to the left 1 place. We said negative 1, and then -1 and 1 makes 0. You can write it in different ways. 2.927 times 10 to the 0. I'm going to write it out just for people to see, but if you stopped right there, that's fine. Okay, question on how that works. For algebra 1, IXL, V.6, you can, and I'm going to say semis because that's today.